So what is discrete data? Discrete is countable. So how many people are in this room? That's discrete. Continuous is not countable because it can be broken up into smaller segments like time, distance, okay? Independent events, it means that they cannot happen at the same time. Mutually exclusive means that one, sorry, hold on, I think I got those backwards. Independent means one does not affect the other. Mutually exclusive is that they cannot happen at the same time. With replacement versus without replacement. So remember, like if you're drawing marbles from a bag, if you replace the marble when you draw it, it does not change the probability. If you pull it out and don't replace it, it does change future probabilities. So therefore not independent at that point. A complement means the probability that something doesn't happen. So it's 1 minus that probability. So if it's a 30% chance of rain, the chance that it's not going to rain is 70% or 0.7. Okay. And then your addition rule for mutually exclusive is that. So a random variable is a variable whose outcome is determined by chance. And again, you can have either discrete random or you can have continuous random. It represents a numerical quantity associated with each outcome of a probability distribution. Usually we use uppercase letters like X and Y, okay? It can be lowercase. I think they're fairly interchangeable. If X is a random variable, then X is written in words. Uppercase X is written in words and lowercase x is given as a number. Okay, your uppercase X is the verbal description. The lowercase x is the numerical description, okay? So, for example, uppercase X is the number of sales calls a person makes in one day, and lowercase x would equal 24, okay? Uppercase X, hours spent on sales call in one day, lowercase x, 6.357 or whatever, okay, etc. And then the last one, uppercase X, the number of heads you get when you toss a three fair coins. The sample space is the following. And so that would be what, if you look on the next page, lowercase x is 0, 1, 2, or 3. So remember, notice in this example, the values are countable outcomes because you can't have part of a head. You can only have whole numbers, okay? And therefore, X is a discrete random variable. All right, so we have a probability distribution. Which is a description that gives a probability for each value. It provides the possible values of the random variable X and their corresponding probabilities. It can be in the form of a table graph or a mathematical formula. And then a probability mass function, or PMF, it is the probability distribution for a discrete random variable. And so over here, that would be an example. Okay, so notations, f of x is the probability that your random variable equals a specific number. Okay, so you're going to see that interchangeable. Know that just like all probabilities, f of x must be between 0 and 1 inclusive. What does inclusive mean? Including the endpoints 0 and 1. So it can equal 0, it can equal 1, but it cannot be smaller than 0 or larger than 1. F of x equals 0 for every x that is not in the sample space. So if you look at this table up here to the right, for x equaling 6, because it's not in the table, that means it's 0. Does that make sense? Okay. What does the sum of all your probabilities have to equal? must equal 1. So there are going to be times I'm going to give you a table of values and I'm going to ask you, is this a probability distribution? You have to verify, does it meet the requirements of the definition? Okay? So looking at these, example 1, can the following tables be a probability distribution, and tell me why or why not? First one can. It cannot. No, because you cannot have negative values. How about the next one? If you add this up, the sum is 0.97. So no, because the sum of P of X does not equal 1 or equals 0.97. I don't care how you say it. And the next one? Yes. Okay, so are all the probabilities between 0 and 1? Yes. Does it add up to 1? Yes. Therefore, yes, it can be a probability distribution. It's because it meets requirements. All right, so if I tell you on example 2 that this is a probability distribution, we know it has to add up to 1. So therefore, you can find the missing value. So this is 0.2. Example 3, a child psychologist is interested in the number of times a newborn baby's crying wakes its mother after midnight. For a random sample of 50 mothers, the following information was obtained. Is this a discrete probability distribution function? No, because it can get divided for, right? Okay, X is the number of times that woke the mother up.
No, discrete means it's countable.
It's countable. 0, 1, 2, 3, 4, 5.
Oh, continuous means
continuous means that it's gotcha. Okay, that's where our confusion was. Okay, so is it discrete? Yes. What else are we looking at?
Does it add up to 1?
It adds up to 1, and they're all between 0 and 1. So if you add this up, sum is 50 over 50. So is this yes? Because, and if I want you to write the actual formal reason why, your answer is P of X is in 0 to 1. You can write it this way or write it all out in words. And the sum of P of X equals 1. So you can either use mathematical notation to shorten it, or you can write out all the words. I don't care. All right, so example 4, suppose Nancy has classes 3 days a week. She attends class 3 days each week, 75% of the time, 2 days, 18% of the time, and 1 day, 4% of the time. Suppose a week is chosen at random. What is the uppercase X equal to? Remember, uppercase X means it's the verbal description. Number of days she attends class per week. What values does uppercase X take on? So what is lowercase x? What can it equal?
Lowercase what adds up to 1?
Lowercase is just the actual numerical values of X. 0, 1, 2, 3. Don't forget 0. How do we know 0 is one of them? Because the percentages don't add up to 1, so it means it's missing something, and then if you use just logical thinking, well, she can obviously just not go to class. Because it's a 3-day class, she can't go more than 3 days. Okay? And then construct a PDF table. So 0, 1, 2, and 3. It told you 3 days a week is 0.75. 2 days is 0.18. 1 day is 0.04. And then you have to find out your third one.
0.3.
Should be 0.3.